So we're going to talk about use what we know from hypothesis testing for one population and use what we know and build on that and look at hypothesis testing for two populations. So let's suppose I have some claims or have some ideas. I think women at WWCC have a higher grade point average than men. I saw some diet advertised on TV. I don't really think it works. And I think that men smoke more than women. So here what we're doing is we're taking a look at comparisons. The first situation we're comparing women and men. The last one we're comparing women and men. And then the situation with the diet we're looking at before and after. So we're looking at an average from before going on a diet and after going on a diet. So how can I address these statements? What would I do? If we look at the first slide, we're going to see that we're going to do some hypothesis testing. And just for some review, what's our hypothesis test look like? We're making some claim, or some claim has been made by someone, or we're testing something. Find some data, and then we're going to interpret the data. What did the data say? We're going to find some test statistics, excuse me, and then remembering statistics is about testing assumptions. If we make an assumption and something occurs that's unlikely, maybe the assumption isn't a good one. So for example, we flip a coin 1,000 times and get 992 tails. If we're assuming it's a fair coin, the likelihood of getting that many tails out of 1,000 is pretty unlikely. Maybe it's not a fair coin. Or if something happens, the probability of that event occurring is not unusual. I flip a coin 1,000 times and get 512 tails. There's no reason to believe that it's not a fair coin. And again, how does a hypothesis test work? We've said before, hypothesis tests basically are all the same except the particulars of a test statistic. So with the two populations, works just the same. We find a null hypothesis and an alternative hypothesis. We determine the level of significance. That helps us find the critical values, and that helps us determine the rejection region. And then we're going to calculate a test statistic as we have before, and then make some statement about the null hypothesis. Do we reject the null, or do we fail to reject the null? And then some interpretation of what that means. So here we go. We'll do one. Do a survey of 84 females, 60 males, and you get some information on GPAs, average GPA for each group, and standard deviation for each group. And let's perform a hypothesis test to determine if there's a difference between men and women when it comes to GPA. So here we'll be doing a test for two means from independent samples. So we're measuring one variable, grade point average, and we're doing it in two different groups, males and the females. So we find the null and alternative hypotheses, and when we're doing tests for two means, we're always going to have the null as mu1 equals mu2, or assuming that there's no difference between the two groups, and the alternative would be that the means aren't equal, or that they're different. So always the two-tailed test. And to make this easy, since these are large n's, what we'll do is just say that the The t represents very closely the z, so we'll use 1.96 plus or minus as our critical values. And then we'll calculate the test statistic. So this one gets a little bit messy, but we've got the difference of the two sample means, then over the variance is squared. So here we've got our standard deviations squared over n, and plugging in the information from the problem. Here we have the mean of the females, mean of the males, and it doesn't matter which way you do it. You could subtract the male mean, or you could take the male mean minus the female mean. The only thing that changes is going to be the sign of the test statistic. Everything else will remain the same. So we plug in our numbers. Here's standard deviation for females. Here's the number from the females, standard deviation for males, n from the male sample, and we get a test statistic of 1.24. What does that mean? Well, the test statistic is between the critical values, so it's not in the rejection region, so we will fail to reject the null hypothesis. From this sample, from this information that we've got, despite the fact that the sample average for females is greater than the sample average from the males, there isn't any evidence to suggest that males and females have different GPAs. We don't have evidence, maybe if we took a bigger sample, if we had a sample of 284 women and 260 men, and there was that difference in GPA, maybe we would have a statistically significant result. But for this particular sample, these 84 females and 60 males, there's no evidence to suggest that overall females have a higher GPA or males have a lower GPA. Again, we haven't proven anything, just we don't have evidence to suggest that the GPAs are different. So here's another one. So you see an ad on TV and it says there's a Krispy Kreme donut diet and it's effective for losing weight. We'll collect some data, 16 subjects. Average weight change was 6.6 pounds. Let's assume that the standard deviation is 10.8, and let's do a hypothesis test for two means for dependent samples. So this is, again, a before and after. It's the same 16 people. Their weight is measured twice, so that gives us the dependent samples. And we're looking at the difference before and after. And again, we're looking at the average difference. Some people will lose weight, some people will gain weight, some people will stay the same, but we're looking at the overall average difference, or the average change. So for these, we're always going to look at D bar, or the difference, average difference. So the null is always going to be that the average difference is 0, which would mean there's no effect or no change. And the alternative will be that there's some change, so that the average difference isn't 0. So level of significance is 0.05. We'll always use that level of significance. Since we have small n and we're using the differences, we're going to look at the t-table, n-1, or 15 degrees of freedom. And from the table, for a two-tailed test, we'll find plus or minus 2.131 is our critical values. Our critical values. So we'll calculate the test statistic, which is simply our D bar, standard deviation over square root of n. So plugging in that information, we'll get a test statistic of negative 2.44. And so since the test statistic is less than the lower critical value, we'll reject the null hypothesis. We have evidence to suggest that the average change in weight is not, in fact, 0. And it seems as if the average difference is a loss. So this would suggest that the diet is effective. And again, we haven't proven that the diet is effective. We merely have evidence to suggest that the assumption of the diet having no effect may not be a good one. And be careful here. It's a small number of subjects. It's only 16 people. However, the math, the formula, takes this into consideration when it calculates a test statistic. Okay, so even though it's only a small number of people, they have a large enough average loss that it seems that the assumption is not a good one. Certainly, you might want to try to replicate this with a different group of subjects, a larger group of subjects, and see what happens. See if your results are replicated. But in this case, it seems as if the diet works. And then one last one, looking at two proportions. So claims that men smoke more than women. We take a survey of women and men, find out proportions of smokers. So the proportion of male smokers is 52 out of 243. Proportion of female smokers is 22 out of 186. Again, for the two sample hypothesis tests, we're always going to have a null that the proportions are equal, and the alternative is the proportions are not equal. 0.05 significance level, which gives us a two-tailed test with critical values of plus or minus 1.96. And we can calculate our test statistic. A little messy, but p hat 1 minus p hat 2. So, and again, it doesn't matter which you choose, whether males are p hat 1 or females are p hat 1. The only thing that would change would be the sign of your test statistic. And then down here, p bar and q bar, how we calculate those. P bar is simply the proportion of smokers in the entire group. So assuming that men and women smoke at the same rate, we can lump them all together. So there are 74 smokers out of 429 people. That becomes our P bar, and then Q bar would be the complement of that, 1 minus P bar. So there's our little involved test statistic there, and it comes out negative 2.61. And again, since this test statistic is lower than the negative, critical value will reject the null hypothesis. Doesn't seem that that's a good assumption. In fact, it seems that they smoke at different rates. And from this information, men smoking more than women. Again, we have to remember we're not proving anything. Statistics never proves anything. It just supplies evidence. And so, again, hypothesis testing for two samples, two populations, pretty much mirrors what we've done with the one population. Null and alternative hypotheses, critical values, calculating a test statistic. And then comparing that test statistic to the critical values. Do we reject or fail to reject the null? And what does that mean? Really, the particulars show up in calculating your test statistic. And of course, choosing which test you're doing. 1 mean, 2 means, independent, dependent, 1 proportion, 2 proportions.